welcome to another episode of Rustacean Station. I am your host, Alan Wyma, and today I'm with Prabhu Eshwarla. I may or may not have butchered your name, and I apologize if I did. He is a software engineer and developer, and currently a blockchain architect. I believe that's how you called your position. And you're also the author of, so it's Rust Servers, Services, and Apps, which is a new book at Manning. As we talked before the show, I've been reading it, and sadly, because I've injured myself, I can't finish reading it at the moment, but I am enjoying everything so far. Why don't you go ahead and introduce yourself?
Hello, Alan. Thank you, and very happy to be here. So, as you say, you pronounced my name perfectly. So, it's Prabhu Eshwarla. Currently, I work in the blockchain, or the broader term Web3 technologies. I'm a blockchain architect, and I am as you would imagine, I'm a strong evangelist of the Rust programming language. And I'm happy to talk to you and your audience today about it.
Yeah, we have a lot. Actually, we have a lot in common, don't we? Because we were talking about before the show. You and I both have a secret interest in a programming language, right?
Yes, I thought I was the only guy who does that, but happy to hear there's other people doing it too. Yes, it's Elixir.
Yeah, I think most of the people on this podcast have heard me talk a lot about Elixir. And maybe you can also give some, because actually the only people who talk about Elixir on this podcast besides me is like guests who are also in that community. But what made you get into Elixir? Sorry for a quick segue, but I just thought it's interesting. Like, what kind of made you get into Elixir, and what kind of things would you use Elixir for versus Rust?
Actually, more than Elixir, what got me to Elixir was not Elixir per se, but it was really the Erlang ecosystem. The way, I think they were the first, or rather among the first in the industry, to define a completely distributed transaction system that is highly reliable. And they kept that going for so many years. And a lot of success stories, but just that, it's still been a very niche area. Like it's not been a mainstream, success story compared to some of the other traditional things you see in IT today. And then because I think the language itself was not very, very accessible to a lot of people, then came along this Elixir, which was actually based on the same technical infrastructure that, Erlang uses, but then it brought in a lot of the modern programming concepts, especially the functional programming concepts. It's a completely functional language. And the moment I started looking into it, and I had not done really functional programming before that, but when I started to look at how I can write the same type of imperative statements, replace things like for loops and stuff like that in a different way, I think it allowed me to see a world where I can express the programming terminologies in a very different way. And I really loved it the first time I looked at it. I said, I'll never look at another programming language. It's so beautiful. I'm going to do it forever, which I do that for whenever I learn a new language. So that's how I got into it. And once I started doing Elixir, then of course I was also into a lot of web development in those days, or even now, of course. But web framework, you don't really do web development without any frameworks. And then came along with Elixir, there was this thing called Phoenix, which they started developing. And it was a fantastic web framework. Again, it made things so productive. It's also a meta program. They used the meta programming language features of Elixir to develop a lot of the code generation for Phoenix. Again, a lot of magic, just like Rails, a lot of magic was there in that framework. Could get things done very quickly, whether it's database access, writing handler functions, everything. So all in all, it was a very pleasurable experience for me to write, web applications using Phoenix and Elixir. So that was my introduction. I also got stuff deployed in production. It was doing quite well.
Yeah, one of the things I think Elixir has over Rust is that they have a very good. Yeah, Phoenix itself is really good. Like it has basically everything kind of bundled up together. I think the only thing similar would be Rocket, but that one's been parked on the side. Actix, I mean, it's like a core piece you have to add on, bolt on things that you need. But for Phoenix, it really is just a complete piece, and it just works and works very quickly, right? It's fun to see sub-millisecond response times when you come from like Ruby or Python.
Right. I haven't been keeping in touch with what the Phoenix ecosystem of late. I don't know if still it's popular or people are using it, but it was a great start when I started looking into it.
I mean, so actually, I'm kind of curious. So when did you actually start working with Phoenix? So then I have an idea about kind of where you were.
This was sometime in 2015, around that time frame.
Oh, that's a real long time. It might be before pre 1.0, I think.
It was just about getting to 1.0, I think, at that time.
Okay. Yeah, a lot of things have changed. Yeah, I'm just trying to think, if you were to create a Phoenix-like system in Rust, do you think it's actually possible? Or do you think it's going to take quite a lot of work to get some of the pieces there?
It's already there. A lot of the web frameworks in Rust have evolved significantly over the last few years. There's a website called Avi Web 3, Avi Web Yet. So that tells you whether, Rust is suitable for web development or not. For a long time, you would say no, web is not suitable for production systems. But some of the frameworks, including Actix and Rocket, which you mentioned, there's Warp, many of these are maturing very quickly. And I think they are getting on par with any other. I mean, I wouldn't say it's getting on par with the other frameworks, but I think they're getting a lot better than they used to. So one of the problems with using Rust is that some of the syntax gets very, very difficult for people. But some of these web frameworks make it easy for you to, or they hide some of those, complexities of Rust. And as long as you know the APIs of the framework, you don't really need to understand the entire, Rust API programming language. So that is where they make it easier to onboard people coming from other programming languages, use the web frameworks. As long as you understand the concepts of web development and you know a little bit of Rust, you can get started very quickly with Actix or Rocket and these frameworks.
Yeah, but I think if we work with Actix, though, there's no. I did see, just took a quick look at the table of contents, and you said like to generate server-side templates, I think you use something called Terra, right? But that's actually not part of Actix itself. It's something you have to kind of bolt on to Actix.
Yeah, but they are template engines basically. You can use. They're just giving you the flexibility to add any kind of template engine you need. Right? You can use the one that comes with Python. You can use the one that's used in handlebars. It's like a plug and play. It's like in some web frameworks are very, very prescriptive. Like you say, take Django. They have their own built-in template language. They have their own built-in ORM stuff like that. But you have other frameworks which let you bring your own stuff and mix it. So it's Actix takes the approach that there are some things that are built in, but many you can use third-party libraries. For example, even the database access layer is not built in. You can use SQLX, which is more raw SQL, or you can use an ORM like Diesel. So that's how it is.
That's kind of probably my one complaint about the web development in Rust is that I wish there was something that was like more conventional configuration where it's like, here's a suite of stuff, even if it included Actix, like maybe an acronym like MEAN or something like that kind of just gave you, okay, you use these things. I think that was something I wish was a little bit more kind of clear.
I agree with you. I think that is one of the things people will miss when they want to start developing in Rust. There's no equivalent, for those kind of stacks that you mentioned, where things just simply, work well together. So there's still a lot of things you have to do in terms of deciding, what libraries you use for what kinds of things, For example, even an HTTP client, if you want to talk to another thing, you can use the built-in Actix one, or you can use, an external one. So at every stage of your development, every technical decision, you're given a choice. But that's one of the things I try to do in the books to see, these are pre-chosen, some of these libraries for a typical web development. And I said, these are things that we've tried and tested. It works well together. You can start with it. But if you don't like it, you can always switch it out and try something else.
That's a good point. Like maybe, do we have to buy the book in order to get the answer for that? Or do you mind to share with us kind of like what's in your backpack if you were to create something?
Okay, so I think we start with typical web development stack. So what are the things that you need to do web development? So let's first start with the backend API, and then we'll go to the front end. So on the backend, obviously you first need to be able to have an HTTP server that you can spin up, configure stuff. Okay, that is built in. Second, you need to be able to serve some static pages if needed. So that is there. Then you need to be able to define some routes, which route and what handlers, associate the handlers with the routes. You can do that here. Then you need a way to maybe talk to a database. Now for the database, there's nothing built in, but I've chosen SQLX as the layer that you can talk to any database like Postgres or MySQL or whatever. You just need to understand the API. But the way I've suggested in the book is you write an abstraction layer so that later on you can always switch over between databases, but your interface still remains the same. I think these are the standard programming concepts. So that's on the database layer. If you want to talk to another external client, you can use the built-in HTTP client from Actix itself, which you can do. So that's on the API. For authentication, for authentication, especially if you want to do things like JWT-based authentication, you have to use some crates, external crates for that. And also, if you want some middleware support that is built into what Actix provides, especially if you want to do some pre or post processing after requests or responses. Of course, then once you have an API set up and running, then on the front end side, of course, you need the template for HTML, especially if you're doing server side rendering. I'm assuming, right? Not a client side application. So you can use any of these. So I've chosen to use this Terra templates, but you can use any template of your choice. And again, you have to use third-party libraries for doing, OAuth and stuff like that. They're not built into the framework, but you can use your own things. But for basic user ID password authentication, you can do this. For cookies, there's built-in libraries available that Actix provides. You can do one for session management. Also, they've got some libraries built in. So essentially, you can do things like, CORS. You can specify with what Actix offers you. Of course, for SSL termination, we have to use some third-party libraries to help you do that, but you can build it into the HTTP server. I think by and large, these are the components that you use for building this thing. So the answer is that there are many parts of it that Actix provides, but it's not as intuitive for you to figure out, how to do it. I think there's a lot of tons of documentation and stuff you have to go through and try it out. And the examples are not great. Especially on the site, you won't find things that are ready-made for you to start using, like starter templates and stuff like that, though they are improving since the time I started writing the book. So that's really what, how I see it. There are other frameworks like Rocket, which also gives you similar things. Maybe they have more features, but when I started, since they did not have async support and I wanted to demonstrate async all the way from, request handling all the way to database, I chose to go with Actix. But in the future, Rocket also, is a good choice for someone who wants to use it, because especially from a user developer perspective, I think the syntax is a lot more friendlier, I think, that Rocket provides.
Actually, this is kind of a good question, right? I mean, you're still writing Rust day in, day out, but actually you're still writing Rust web services day in, day out, or not?
I've been writing web services. I think whole of last year I was spending, I wrote a lot of web services, but more recently I'm switching to more writing the backends of blockchain systems. Yeah, you can call them backend services, but they're all essentially blockchain clients and nothing, but they're really a backend service.
The reason I asked is because it seems like the web space is getting more and more crowded, right? You have like Exum, Warp, these kind of things. Do you have any opinion about which one you think is maybe better or easier, or which one you think maybe it's not quite there yet?
Very, very subjective question. I don't know if I want to answer that. It's really a preference. I've tried all these, all are good. I've tried Warp as well in the early stages. There again, it's a very it's got its own unique syntax, interfaces that you have to follow, but it's also a very, very enjoyable thing. The style of programming decides sometimes, which ones you like. Also, some people prefer to be given everything like, a complete set of tools available for you rather than you going and trying to choose things. If you want everything ready made for you, or if you want something that is more mature, you really go for either Actix or Rocket. If you're a kind of guy who does your own stuff, bring your own stuff, then you go for these smaller frameworks, which do some things quite well, but then a lot of add-ons that you have to add to make a complete web application.
Now, do you think that this is something that a beginner can do, or this is really going to be something that will take them some time to kind of start to strap in together? Because like you said, there's a lot of pieces you have to kind of bolt on.
To get started on any of these frameworks is very easy. It's very easy for you to, write an endpoint where you can get some information, post something. All that stuff can be very easily done. It's only when you want to get into more of the production considerations, like all the security, the authentication, SSL, and all those things, then you start to worry about, how do I do all this? Is it available within the framework, or do I go outside? But for the bare bones stuff, to get started, all these frameworks are equally easy to use.
Now, do you think that you can actually basically build everything front to end, like basically, because I mean, we also have Vue too, right? Or in probably other kinds of front end frameworks where you can generate WebAssembly, things like that. Can you really actually write basically your entire stack in Rust, similar to where you can take Node.js and write everything in kind of Node or JavaScript?
You can write entire stack. See, you're talking of the WASM-based front ends. That's always an alternative. See, you can do server-side rendering, wherein you generate your dynamic HTMLs and you present it to the user, and you can do backend APIs in Rust, and the entire end-to-end stack. You have a working stack. So that is possible. The second possibility is where you have the API server in Rust, and then you use a front end like a React or whatever, which just authenticating using APIs, and you do all the rendering on the client side. These are the two predominant models. Now on the client side, instead of using something like React, you can choose to use Rust, and that's where you use a framework like Vue, where you compile it to WASM and have it run in the browser. But that part is still developing. I don't think it's in a stage where, at least a year and a half back when I started writing the book, it was not mature. And I don't think even today it's still in a stage where it's production ready. But a lot of progress is clearly being made in that space. And a lot of people are looking forward to doing that, because they say, if I don't like JavaScript, I want to do Rust all the way. So these frameworks, I think, will mature over time.
Yeah, I definitely think so also. I kind of want to dig more into your background, right? Like, who are you, and why should I listen to you, and why should I, what kind of person are you that I should listen to your book or read your book? I mean, can you talk more about like your history? Like, when did you start programming?
Programming right in grad school, I'd say. So I have a background. I did a master's degree in electronics and control systems. So that's my foray into programming. I tried to write, these control systems. Everything is a control system. You have an air conditioner, a fridge, anything, even a cruise control on a car. Essentially, you have a set of inputs, you monitor a set of outputs, and then you try to control it back to a certain parameters, right? And I was trying to write a program to map them. They're all mathematically related, the inputs and the outputs. So I wanted to draw some graphical stuff, depict the correlation between these. Well, I wrote the program. My professor, I submitted this thing to the professor, and it all went well. I got my grades and stuff. And little while later, what happened is one of my juniors came and we met in a social gathering, and he said, "Hey, are you the guy who wrote this program?" I said, "Yes." And the first thing he said to me is, "You wrote some really bad code." I said, I didn't know what to say. Well, I told him, premature optimization is the root of all evil and stuff like that, but I don't think he would listen to that. But anyway, so that was my first foray into programming a while ago. But essentially, I mean, since then, I've been programming a lot in all kinds of things, Java, within the .NETs of the world, and then, moving on to, of course, the standard C and C++. Then I've done JavaScripts and even little-known programming frameworks like Elm, which I did before I got into Elixir. I did.
Speaking of that, I also love Elm too. So
wow.
Everything you should think is unknown. I think I know what it sounds like. Sorry to interrupt, but it just sounds kind of funny.
Yeah, that's good to know. And then a lot of Python, and I did some Golang programming, and then I'm really a dabbler in different programming languages simply because I think each programming language gives you a different perspective of how to attack problems. It tells you how you can define the problem in different ways. But eventually, I was still looking for the holy grail of programming, right? All said, and that's the reason I went on switching from one language to another. I had a day job where I had to work on some of these things, but also I was learning things on the side, trying to find out. And eventually I got into Rust, and then I knew this is it. Because when I saw it, it appealed to me, at least the philosophy of Rust appealed to me so strongly that I said, this is the programming language that I'm going to stay with. So that's really my thing. I've built all kinds of systems, for, the banking and financial services, for manufacturing, the public sectors. So different systems built and delivered. So done mobile development also, with all the way from hybrid frameworks like Ionic and React Native and Flutter. I was one of the early users of Flutter. I built an app, and I know you have another podcast on Flutter. Sometime in 2000, I think in 16, I did a app on Flutter, which I liked very much. And then around 2017, late 2017, I got into the blockchain space. And after I got into blockchain, and that's when I started to hear about Rust, because I saw at that time that a lot of the frameworks, a lot of the blockchain teams started to use Rust to build their underlying infrastructure. One of the more famous ones was what Facebook was trying to do with Libra, right? That was also Rust based at that time. And then once I got into the language, I started to really love it, and I got full time into Rust. That's my programming journey. But more than programming, even though I talk a lot about the programming language, it's not really the programming languages. What I realize is that you have to understand there are certain concepts. The concepts are so important that they apply more or less to writing good code, writing reliable code, writing code that is readable, maintainable. I think the maintainability, a lot of people focus on writing code that is fast. You choose a framework because this is damn fast. The benchmark says it's fast, but that's not the way I choose things. What is most important is over time, you're not a single person writing code. Software has to be maintained for years and years. And unless you write something that others can read, right, your software is completely useless. So it's very important to have those, and also writing testable code. I give a lot of importance to making sure you write. Test-driven development, we've been talking about for a long time. It's a very good concept. It's not always possible to do every single day TDD, but then at least you have to make sure that you've got a set of, regression tests and, with integration and smoke tests so that new people come on board, they know how to enhance and maintain the systems. So some of these fundamental programming principles are extremely important. Languages come and go, so yeah, that's where my philosophy is with respect to writing systems. Another important skill where writing systems is also about mapping the business domain, right? In most cases, I've built a lot of the applications. It's not enough to, at one level, you need to understand, how to write data structures, how to write good algorithms, for searching, sorting, all that stuff. But then when you have another world out there where you have business requirements that tell you, that deal with completely different set of entities. They don't deal with linked lists and hash maps and stuff like that. What they deal with is accounts and customers and orders and invoices and stuff like that. So that is where it's important for you to be able to say, okay, what is that real world entity? How do I model that in my system? And more likely we are going to take that and see if you can convert it into some kind of a data structure. So it's very important to understand how to model the real world system in a way that can be maintained, where you don't mix state and data, keep it clean. At the same time, you can enhance the data model, you can enhance the business logic, and still keep the whole code maintainable. So that is the other aspect, being able to map the business requirements onto your system, and also understanding the whole architecture. It's never that you build one system or one server that does everything. Today no system is an island. Every system has to talk to a lot of external systems to get anything meaningful done. So in that sense, you also have to think of the entire architecture, right? Whether it's to do scaling, whether it's to security, distributing, and also this whole thing about monoliths versus microservices. Like, it goes back and forth. If you too much of a monolith is bad, too much of microservices is very complex to manage, especially for the smaller companies and players. So you got to find the right balance. There's no single answer for what is the right architecture for a system. It changes for the same company. It will change depending on what stage of evolution you're in. When you're starting out with an MVP, you're just going to write something that's going to work. Don't worry about over engineering. Just make sure you have the right product market fit, get it working, get it in front of the customers, get the feedback. That's the most important thing. There's no point trying to write code that's perfect, right? But once you hit that product market fit and then you go to the next stage, you can always bring more people, and then you most likely have to throw away your entire code. Don't be afraid to throw away your code, because that's what it takes. Sometimes you have to rewrite it. That's okay. But as long as you have a customer base and is willing to pay for it, and you can always do that. So the point is that there's the kind of architecture, the kind of design that you do completely depends upon it should be in tune with what your business requirement is. And so some of these all these other software factors also play a big role in software development. So while there are technical considerations for choosing a language or a platform or whatever, there's always all these business considerations which you have to take in mind. You have to think about how the system is going to be maintained. Is it easy to find people to maintain? Like if I write something in Elm, I love it, but it doesn't mean that I want to recommend this to a client, because it's very, very hard to find someone who's as passionate as me to do Elm programming. So you got to look at what is the cost of acquiring your developers and onboarding people. It's not acquiring, it's cost of onboarding resources, especially if you want to scale up. How do you bring 10, 15 people over 6 months and very quickly bring them up to speed and train them? So many of these factors are very important in deciding ultimately how you build systems. And those are the things that I have learned over time, rather than just picking a programming language or a framework.
The comment you made about Elm is very interesting, right? I'm aware of Elm, of course. I play with it. I actually put something kind of into production with it. Now, the benefit of learning Elm is that Elm is so similar to Rust, I think, where they kind of force you to handle a lot of these edge cases that you wouldn't normally have to handle with traditional languages.
Pattern matching.
Yeah, the exhaustive pattern matching, right? But that's kind of really a big benefit, right? Because then it forces you to really think about what things may go wrong, and then you end up having a system which nearly never goes down. Now, what about that as an argument? I mean, if you tell your client, hey, listen, I want to build it with this thing, the benefits is that this thing will basically never crash. The only bugs you're going to have is basically logic bugs, which we can do our best to test against. And because we have very much a typed system, it's going to be pretty okay. And we're going to be writing tests and things like that. But the negative is that people don't really know this language. Like, I don't know, that's a pretty tricky situation, because obviously as a business owner, you don't want bugs in your system, but you also want to make sure that you don't lose out because, if something happens to you, you can't work on the system anymore. Who's going to be the next guy? That's a very difficult question to answer. Both of those sound very good to have.
Yeah. So again, it depends on what kind of, teams you're talking about. If you're talking about large enterprises, I don't think they'll ever take a bet on a niche programming language, because they need to maintain systems at scale. Many of these systems are legacy, written over many, many years. Let's say you have Java programs written 10, 15 years ago, and they're still running in production. So you really have to do a lot of data program maintenance. And even when you're talking of writing new projects, you find something more adjacent. Like, if you're doing Java, maybe you look at, doing something like Scala or something which is more any other, JVM based language. And, many of these enterprise programming languages give you all the features. It's not that they don't allow you to write good programs, right? Even in Java, you can write programs that does exhaustive pattern matching. It's just that you don't use those constructs, but you do the same thing in a different way. You do a lot of checking, and then you write a lot of test cases and make sure all the edge cases are covered. So it's not that you cannot do it with typical, mainstream languages. It's just that some of these languages make it easier, or they enforce it for you at compilation time. So that's the difference. So there's always a cost benefit analysis, while developers always want the latest and the greatest. As a team manager, as an engineering lead, you always have to look at longer term sustenance and maintainability, and ability to hire and retain people in a particular technology. So people are cautious, the large enterprises, while looking for niche programs. But you see, in the smaller companies like the startups, you have a lot of flexibility. As long as the founders are okay with it, you can pick your stack and go with. And like I said, you start with a stack, you can always evolve the stack or replace or throw it entirely. That's okay. So you have more flexibility in the smaller companies to pick the language of your choice.
Now, I have to ask, is there any technology where if they said, hey, we're using this, would you just say, no, I'm not going to do that. I'm out of here, like PHP or something like that? I'm just curious if you have anything where you just don't want to touch it.
Okay, I don't want to offend people, listeners. I have done a lot of Java, but I don't want to do any more Java.
I don't think people listening to the Rustacean Station are really cared so much about Java, but I'm in the same boat. Nearly every Java project I've ever worked on, I feel like has been a disaster where like we launched it and then like, I don't know, the memory just ballooned for some reason. And I have no idea what's going on.
Yeah.
That's where I wish we had the observer like we have in Erlang so we can just hook in, see what the heck is going on. But the observer life systems in JVM is not as good as the one in Erlang.
Right.
Okay. No, I really appreciate your feedback. I think a lot of that resonates with me and it sounds very similar. I still have my biases, still have things I want to play with versus other ones. But yeah, I agree. Like I've worked in a couple of big companies and yeah, it's very much can we find another similar cog to put into this position or, or not? And if we can't, then this kind of choice is not good for us because we need to be stable, right? We have shareholders, we have all these things. We can handle having bugs, but we cannot handle not finding bodies to fill positions is what I feel like the basic idea is. It's kind of funny. When I first interviewed at a bank, like I remember the manager talked to me and he basically said, because my whole thing was I didn't take the job first. Like I came back later on to that same company and I didn't take the job the first time because, I was a little bit worried because I asked them, I said, what would I be doing? And they said, I don't know. Right. But he kind of explained it to me, the manager kind of explained to me that, yeah, they don't know because it first of all takes you to 1 to 2 months to kind of onboard because they have to do background checks, everything else. By that time, you don't know what team you're going to be on because at 1 to 2 months things happen, right? And also the way that banks and big companies usually work on is that they stack up the resources and then when they need them, they're there. So it's okay for them to pay you to do nearly nothing. But because when they do need you, they're there and then you could start right away, which is kind of the different mentality where a startup would be, we don't need this guy. Oh, now we need him. Get him to come in here like tomorrow. It's totally different type of thinking.
Right. I mean, there's a saying that nobody gets fired for picking Microsoft. Like that, nobody gets fired for choosing Java or or .NET for doing, enterprise software.
Although I do feel a little bit weird picking Java nowadays because I think Oracle kind of backed away from working on the compiler these days. So I just feel a little bit strange to choose Java when I think the big reason to choose Java before was that you had a rather large company that was continuing to work on it, which I think is not the case anymore if I understand what's been going on recently.
Yes, right. But the ecosystem is so large that it's kind of self-sustaining now. So I guess then that's where it is. Any programming language or technical new technology, until you reach a critical mass of people using it, it's always a question. But after that point, after that inflection point, the community takes care of it. So especially if it's open source development, that's the beauty of open source. As long as there are people willing to contribute and continue working on it, you're safe there. That's why JavaScript is still one of the most popular languages in spite of not being the best programming language.
I mean, first of all, there's no other competing technology that's in the browser natively that I can think of. Maybe WebAssembly would be the only other one, and that one's still developing.
Yeah, I was talking of more JavaScript going on the server side also.
Yeah, that's a little bit scary for me because although you have async, you still can block the thread, which would cause big issues. But I think the same thing can happen for Rust too, because the way I think Rust, like Tokyo, I think the way that one works is similar to Erlang with this idea of green threads, where you have a bunch of kind of smaller routines that run and they can get flipped around, something like this. There's a scheduler, right? Maybe you have more input than I do about this.
Yeah, so Rust does not have a built-in runtime for async, though it's got some primitives for asynchronous programming built into the language, like all the futures and async await keywords. But the runtime itself, they consciously decided that they won't include it in the basic programming language. So at one point they had green threads not included. Now they moved away from it. So the way it works is that it's really a concurrency model. There are very broadly two concurrency models. One is, which is tied to the number of threads in the system. That's multithreading as a concurrency model. And the second one is really the asynchronous programming. Now, async is not an exclusively different model because async can also make use of multithreading. But here is how it works. So let's say you have a 4-core processor. The whole idea is that, as processors become cheaper and, you can condense more transistors and on a single chip, then what happens is you're able to add more cores to a machine. And the question is, unless you're able to write software that can take advantage of these multiple cores on a machine, you're really, wasting the compute that's available to you. So what you do is you typically, let's say there are 4 cores, you can have 1 thread per core, which means whenever there's a task that is to be done, at the same time, parallelly, you can execute 4 different tasks. Now, how async works is that async, but there's a problem with this method of thread-based concurrency, because the cost of switching threads is expensive, because you got each thread comes with its own, the memory layout allocation has got its own stack, and whole range of things that you have to context switch, and so it is a little bit slower. So to avoid that, async gives a model wherein on a single thread, right, if you, let's say in a single thread you're making a database call or you're making a network request, that thread blocks until that is complete. You can't do anything much with it. But then if you do an async programming on a single thread, what happens is you actually go to a point. Let's say you make an asynchronous call to a database, and when you're not getting a response back from the database, as long as you don't have it, you can cede control of your program to the scheduler, the runtime, async runtime. Then the async runtime can schedule other tasks. We call it green threads or whatever. It can schedule these tasks. These are very lightweight, not like the typical operating system threads. So you can switch and perform multiple activities. And when the database response comes back or the network response comes back, you can again continue executing. So that is what this async runtime does. Now, async runtimes can work on a single thread, or you can schedule these runtimes on multiple threads. So you can make use of the multiple cores, parallel processing. At the same time, you can do true, concurrency on a single thread. So, and that's what, the runtimes like Tokyo or Async STD, that's what they do.
Yeah, but the one thing I wish was more settled is that you can flip-flop around different async runtimes, because it seems like once you choose a async runtime, you're kind of stuck with that one. It's very difficult. We had a guest on here before who does ZBus, the ZBus library, and he basically somehow managed to make his library async runtime independent, which is not easy, he said, which I still think is kind of weird. It's like, why is it that I need to bolt on an async runtime? And even then, I have to be careful because they're not really interchangeable, right?
When you look at both the runtimes, Async STD and Tokyo, both of them try to model after the Rust standard library. They kind of replicated the similar APIs, but on the asynchronous side. But having said that, you're right. It's not so easy once you choose, let's say Tokyo. It's not so easy to switch over to another stack. Yeah, I agree with you. But I don't think it's every day that you decide to switch. And why would you want to switch runtimes, dynamically? It's a decision you make, kind of once in a project, more or less, unless you really run into any significant production issues.
Well, let's go back, right? So if I'm putting together my stack for my web server, what if one of my things I want to use is using async standard as opposed to mostly everybody else is using Tokyo? That's where I'd have an issue, right? But then now I think you can, right? You can bundle 2 different runtimes, but that's really not what you want to do, right? At least to me, I feel like such a waste to have 2 runtimes, but I don't know how heavy that really is. But something like that, where you have these oddball things, that's where I think the situation becomes a little more complicated. But judging by your eyes, maybe I'm speaking something wrong, or am I?
No, you're not. I mean, your point is valid. You should be able to switch libraries, but runtimes are complex pieces of software. So it's not as easy as switching a database access layer or an HTTP client. So yeah, it has its complexity. It's not impossible, but it takes some effort to do it.
Yeah, because I mean, I'm aware that like Tokyo doesn't work for every single use case. Like, I don't think it would work for, maybe it doesn't work for like embedded devices or something like that. You'd probably have to use something else. But yeah, I mean, like I said, I've had situations where like I've wanted to look at a library and it was using something else as their async runtime. And I was like, oh, that's not so nice. Everybody else is using Tokyo, but why are you using something else? Why you got to be the oddball? And then I have to debate if I really want to use this thing or not, or try to figure a way around it. But yeah, that's not the nicest part. But actually, there's a big benefit, right? The other thing too is actually I kind of like that Rust is small, right? Because if there's a problem, you can just upgrade the library rather than having to fix the patch release of the Rust software. That I think is huge.
Yeah, Rust standard library I think is quite self-contained. It's small, but it's also, you got most of the things that you want to do, without having to reach out to external libraries most of the time. It's in that sense, it's like Golang. Even there, you can have practically everything is built into, including the networking layer, everything. So it's only for certain specific pieces that you have to reach out to the ecosystem, but otherwise you can do a lot with the standard library.
Actually, now I want to take a switch over to talking about like blockchain, right? Because you're doing some interesting stuff in blockchain, and I think that's really fun to talk about. Like I said before the show, you're the only person who I've interviewed so far who's actually working in blockchain that I know of. And so I've heard a lot of people saying they don't want to work in blockchain, but they want to work with Rust. So do you have any kind of input about Rust and maybe why Rust is a good choice for blockchain and what you're actually doing with it?
So the blockchain is a very adversarial environment, and it's a very resource constrained environment. And the implications of these is that you have to write software that people cannot exploit. As such, in a traditional data center or cloud-based environments, we have enough and more of security challenges that we're dealing with. In a blockchain environment where you don't have any one organization that is locking up your servers and your access, the challenge is multifold. And you also have the additional problem that you're dealing with malicious actors who can actually decide to change your entire transactions, okay, which is not the problem you deal with in traditional data center solution, wherein you have administrator access to a server and only the administrator can modify if at all. In a blockchain there is no single administrator who has control over the entire system. Practically everybody owns it. So that's why I said it's a very highly adversarial environment. And second is resource constraint. If you look at applications that you write and deploy on the blockchain, you look things like Ethereum virtual machine, they are very memory constrained. They're like a sandbox environment, very memory resource constrained environments, and you've got to write software that fits into that. And every operation is very expensive because there's no central company that's paying for your compute and storage and all that stuff. The users have to pay for it, right? Every operation. So you have to think through when you write code that the implications of what does it cost to do a simple read access or a write access. What does it cost? You've got to think about those kinds of things. So because of these two reasons, being adversarial and being resource constrained, I think Rust, you can start to see where Rust starts to fit in. On the adversarial side, what happens is by default, Rust lets you write safer programs because the compiler itself has your back with all the programming language constructs. For example, making sure there is no memory leak, there is no data race conditions that you can exploit. So all those typical things which you see in C or C++ programs, you don't have it here. And secondly, it's extremely efficient, it's fast, and you can have a very small memory footprint for Rust programs. And that's also very important for blockchains because you want anybody, just about anybody, to be able to run your blockchain node software. You don't need, you cannot make the barrier to entry so high that only large organizations can run blockchain nodes. In a public blockchain, anybody should be able to run your blockchain clients, download transactions, verify transactions, submit transactions, all kinds of things. So your resource footprint, your memory footprint, your resource utilization, your performance, your security, I think all these features very naturally fall into what is kind of the ideal environment for writing blockchain kind of application. So I think that is where Rust is, I feel, is a very good language. And this is vouched by the fact that many blockchain projects actually have started to use Rust to build infrastructure for blockchains. So yeah, so that's where I would say Rust is not the only language. There are other languages which people use, but Rust is becoming quite popular. And it's not just the infrastructure layer, it's also in the application layer. You'll find that Rust is, interestingly, you will not choose Rust for writing an application typically, right? You will use Python or JavaScript or whatever in the traditional Web2 world. But you have things like Solana or even Cosmos or Near protocol. All these are giving you the ability to write smart contracts using Rust as a programming language. So not just the underlying networking consensus, not just those areas are written in Rust, but also the applications themselves are written using Rust. So it's like the Rust stack all the way in blockchain. So Rust is more popular in blockchain than I think I would have thought, I would have imagined.
Actually, I agree with you about all these things too. Like I would just pull up the website next to me. I know they every maybe 6 months or something, it seems like Rust always changes their slogan. Like now the slogan is a language empowering everyone to build reliable and efficient software, which I think you definitely hit on that, the reliability and the efficiency. But now I want to ask you something. I remember seeing on Reddit, I don't know how long ago, 3 to 6 months ago, something like that. People were talking about Solana and how Solana was having issues. And then they were kind of pointing to Rust, which is interesting. Like, is this true that Rust is to blame, or was it something else? Because Solana is probably the most successful Rust-based blockchain technology out there that I know of.
Yes, basically Solana is a blockchain that has, the blockchain trilemma, which is, you have three parameters. You have the security, you have the scalability, and you have decentralization. Every blockchain grapples with deciding which of those two you want to have. You cannot have all three at the same time. You can only have two of them at the same time. Now, Solana has prioritized security and scalability and not so much the decentralization. So it's more a centralized chain compared to, let's say, Ethereum. But then they have a protocol, consensus protocol, that lets you, achieve high transaction throughput at the cost of decentralization. And the flip side of their model is that the way their, consensus engines work is, you need very powerful machines to run that. Okay. Now, I don't think I would say Rust is the reason for that. It's more the way they've designed their algorithms that requires you to have these, big servers. Not so much because they're using Rust, because I'm pretty sure if you had written it not in Rust or in some other language, I don't think the problem would have gone away. It's a protocol level issue, not a programming language issue. That's what I'm trying to say.
Yeah, actually, that's what I think I read is that it seems like there's definitely, I'm trying to remember, and I may get this one wrong. You probably know more than me because you're in this area. I think I saw that people were saying that Solana, although it is blockchain, should be decentralized, but this most of the servers are kind of run by Solana themselves, or whoever was running Solana. Therefore, like they had an issue, and it was because something with their servers at the time. This is back in June, I think. I'm trying to remember what it is now, but like it seemed like there was a big centralized aspect with Solana because of something like they run most of the nodes themselves or something like that. Do you remember this?
They do have, I don't think the Solana Foundation themselves run all the nodes. They've got a set of external validators. But I think the point is this: a blockchain, you would not expect, let's take a traditional site. Let's say there's an Amazon site or a Netflix or whatever. You can actually centrally shut down that site and make it unavailable to people. That's possible, right? And then you can restart the servers. If somebody tells you, you can restart all the servers. But in blockchain, you don't expect that. You don't expect that, at some day you tell all the blockchain nodes saying on this point, you shut down everything and restart everything. It doesn't look like blockchain. It looks more like a client server architecture, traditional Web2 program. So that's where the problem with Solana comes. And Solana has had a lot of recent outages, as recently as 1 or 2 days ago also, where it's been down for several hours together. And the way they coordinate this is, they of course have their own Discord groups and stuff like that. And then they ask all the validators come together, and then they say, okay, at this time I'm giving you a patch upgrade, you all upgrade it, you shut it down or restart. So it begins to sound more like the centralized operation being coordinated, stuff like that. Of course, you have to do that for any upgrade. Even for Ethereum, you have to coordinate across all nodes. But the way it is done in Solana seems it's more centrally coordinated than it is for the other blockchains. And I think that is the primary challenge that people are seeing with Solana. Because at some point, if the combined validators have got the ability to get together and to decide to do something malicious, it's not very difficult, because there's only a small set of validators who hold a huge stake collectively to be able to influence the future direction of the blocks. So that is where people worry about using Solana as a technology. But there's a lot of other reasons, I'm sure, for why this is happening, but primarily this is it.
Yeah, actually, do you mind to explain a little bit about this? Because like the way I understand blockchain is like, you have your software, you send it out, it kind of runs by itself, it's kind of organic. But you mentioned, and it makes sense, that at times you have to actually upgrade the system. So how do you coordinate upgrading? Like, it just doesn't make sense to me. Like, I'm so used to, opening up Windows, going to update, and then waiting for Microsoft to tell me what I need to update. Like, how does this actually work for the most part? Do you have any idea?
Yeah, I'll take an example of a traditional system, a database driven system, versus how blockchain databases work. I have a set of, take simple banking transactions where I have some money in an account, I do some debits and I credits, and I transfer some money to somebody else. Each of this is a transaction, right? And all these transactions are recorded in a row. Each row represents one transaction in a database, typically. That's how we design it. Okay. And the later transactions, once you have previous transactions, then the future transactions are added at the end of this thing, at the table, database table. Now, the way transactions work in a blockchain is that first thing is there is no central database server to which you send all the transactions and where they're recorded. Every transaction is broadcast, first of all, to a set of nodes. You don't know whom you're broadcasting to. You're broadcasting in a network. Okay. And there are people who are running pieces of software called blockchain nodes or blockchain clients, which is the core. For every blockchain, there is a particular type of node. For example, if I want to participate in the Ethereum blockchain, I have to run an Ethereum node. If I'm running on Solana blockchain, I have to run a Solana node, right? They're not interchangeable. So let's say I'm running an Ethereum node. I have my own clients, whether it's Geth or whatever I run with it. And then these pieces of software are both servers and clients. Typically in Web2, you have a server and client distinct roles. A browser plays a client role. Backend API plays a server role. In blockchain, the client, each node is both simultaneously a client and a server. It's a client because you can submit transactions to the blockchain from that node. It's a server because it can process incoming transactions. So what happens is anytime somebody submits a transaction, you connect from your wallet, you sign the transaction, and you send the transaction to your nearest blockchain node. Now, the nearest blockchain node takes it, validates it, and then propagates it further to every other any other node who cares to listen, right? Now, what happens, what is very critical is these transactions are not individually recorded like a typical database. These transactions are grouped together into what are known as blocks. And a block is basically representation of the state of the blockchain at a particular point of time. Okay. So at this time, let's say Ethereum produces a block every 15 seconds. First, now right now, this is the current state of the blockchain. After 15 seconds, the state of the Ethereum blockchain changes to something else, and that state change is represented by these new transactions that have come in. So in the first block, let's say I have Prabhu or your Alan, you've got a balance of 10 ETH in your account. That's a lot of money. And then in the next account, Prabhu sends some money to Alan, and then you have 15 ETH. So the state of the blockchain has changed because the balances associated with you have changed. So like this, there are many user accounts, many transactions. So each block represents the state of the blockchain at a particular point of time. Now, where the challenge comes is that who creates these blocks? In a traditional database, you have one single database and that database records everything. But in the blockchain, the big challenge is if I'm running my node and you're running your node, now who gets a chance to create that block? Because whoever creates that block is actually representing is saying that is the truth state of the blockchain. That is the gold source. So a lot of people, the way it works is that because nobody's paying me to run my node, nobody's going to pay you to run your node. So we need some incentives to run our nodes, right? Traditional companies have got different ways of getting revenues. You can do subscription, you can do advertising and stuff like that. In blockchain, people need different kinds of incentives. So what happens is blockchains, at least the public blockchains, they give you an incentive that if you are able to produce the next block containing a set of transactions, then you get paid a certain amount of native tokens. And in the case of Ethereum, it is Ether. You get paid, the native tokens. So everyone who runs a node, if you want to participate in creating blocks, what happens is you want to be that guy, so that because it's very attractive. Today I get ETH at a present price. I know the price is going to go up, and it's very valuable for me. So we all compete to create the next block. It's like a game theory. So that is where the consensus algorithms come in. Now, how do you decide who gets to create the next block in the chain is what is decided by what's known as a consensus algorithm. Consensus means Prabhu produces the next block and everybody agrees that this block is valid and we're going to use this as the next block in the chain, right? So first block Alan produces, the second block Prabhu produces, and then all of us, let's say 5 nodes are there, all of us agreed that these two are the blocks 1 and 2, right? So basically the block 2 contains your balance is 15 ETH, remember, right? That's your state. So anytime, nobody can take that money away from you. At any point of time, you can actually use your blockchain wallet, your private keys. You can withdraw that money or send it to anyone because you have exclusive access to it. Nobody's going to deny access to those funds to you. The problem comes when somebody else says, hey, block 2 is not the one that Prabhu produced. It is something that John produced. Who's this guy, John? He's another miner. He says, no, I have created a set of transactions and that is the real set of things. So people with enough, either they have staking power or computation power, depending on the consensus protocol, you can actually alter the kind of blocks that are in the chain. So there'll be block 1 is common. Block 2 in one chain can be my block. Block 2 in another parallel developing chain can be John's block. And over time, if people have to decide whether they want to build the third block on top of Prabhu's block or on top of John's block. You see the picture. So there are parallel chains that can develop, but eventually at finalization of the blockchain algorithm, at least you can have, let's say Bitcoin, use the longest chain algorithm. Whichever block the most number of people decide to build on top of, that becomes the longest chain, and that becomes the source of truth. So you can see how people can misuse the system. If there are enough block producers that get together and say, hey, I know that right now Prabhu's block is the right block, but then I don't want that. I want to change the state of blockchain. So let's all go and start building on next block on top of John's block. So then you can alter the state of the blockchain. And then what happens? The record of you having 15 ETH is lost in the system because in the other block, that record may not be there. That's why I said it's a very adversarial environment. And, security is very important. And deciding how to create the next block is very important in these blockchains. So I think your question was around, how do we do this? So as long as we have a way by which we make it more difficult for people to do these malicious activities by doing some kind of, penalizing people who are gaming the system, then you have a network where things are secure. And that is where decentralization happens. So this is the concept of forks. So you can have multiple forks, but the longest fork can win, and that is the blockchain. Now your question was about upgradability. Now the same forks can happen when you upgrade software. So let's say the protocol changes, and let's say the syntax with which you create a transaction, the way you encode it, something changes. You want to upgrade it, you want to change the hashing algorithm, whatever it is. Then what happens is all the nodes have to speak the same language, which means every node has to be upgraded with the latest version of hashing. Otherwise, you will get a transaction, you won't be able to recognize the transaction because your security protocols have changed. So that is where teams have to coordinate this upgrade of nodes in a way to say that, hey, if you don't use the latest software, you may continue to produce blocks, but those blocks may not be added in the main chain, because whatever from this date onwards, whatever blocks are produced using this latest version of software will be the canonical chain. Anything else will be a chain, but that is really not valid anymore. Okay. So that is where this coordinating software upgrades over blockchains becomes all the more challenging, because there's no single person. In the case of Ethereum, you have tens of thousands of nodes that are running. So it's not possible manually to call everyone in a conference and say you upgrade it. So you just allow the community to decide, and just hopefully they will upgrade, because that is when they have a financial incentive to upgrade, because that is when they will be able to earn ether by producing blocks. So there's a built-in incentive for people to upgrade on time and do it. Whereas in the case of a centralized blockchain, somebody calls for a meeting and says, okay, now all validators, you upgrade it, then it becomes more like a traditional operation. So in that case, also upgrades are much easier. It's like saying, from today I'm going to upgrade the next version of software on all these servers, and you deploy it, and then boom, the clients can access the latest software. So that is the difference between centralized upgrades and decentralized upgrades of software. I don't know if I'm making sense, but that was the try to paint a picture.
No, that definitely makes sense. But I'm thinking like you'd have to run a large amount of servers with the latest version in order to push people to upgrade, right? Because like if let's say that, everybody has one node, even the guy who started up Ethereum or cryptocurrency X, he upgrades his server and he wants everybody else to upgrade theirs to the latest version. But then like what kind of power would he have if he's the only one who upgraded so far? You know what I mean? Like you'd have to have, like you said, some kind of consortium that would kind of push everybody forward, but that is really tricky to do. So in the end, yeah, you have to have some type of centralized part of this to make it work, right?
Yeah. So the coordination in a way is done by the community. Okay. It's not an organization, it's a community that says, okay, this is all going to come out on this day. This release is available for you to download from this site. Do it. And that's where they stop. They're not going to force you to download. Unless you have an incentive to download, you will not do it. For example, there are two types. There are multiple types of nodes in blockchain, but one type of classification is nodes that actually produce blocks, nodes that don't produce blocks. They just listen for transactions, and they want to get let's say you want to query your balance. You don't need to be a block producing node to be able to query your balance on the blockchain, because anytime there's a block, the same block is synced up on every single node. So in that sense, if you don't upgrade your software, you won't be able to see your latest balances. So you have an incentive to upgrade the software to the latest version. And the block producers have an incentive to upgrade because they will get money out of it. They get tokens out of it. So I think that's what I'm trying to say. So you don't have to force people to upgrade, because the incentives are built into the system in a public blockchain. In a private blockchain, it doesn't work like that. You have to push people to do it.
Yeah, I understand. That's interesting. It's pretty interesting style. Makes sense. But yeah, actually, what I also want to talk about too, which is quite interesting, what you're currently working on, I think is truly interesting, because what people really like about the blockchain is everything is kind of open and people can see what's on the blockchain, right? But you're also trying to build something that's like trying to make it not so clear about some pieces, right? Maybe I'll let you kind of talk about that more, but I think you used the word secret.
Yeah. See, blockchains basically it started out with being a currency like Bitcoin. But then the next generation of blockchain, which is with Ethereum, allowed you to define any kind of asset on the chain. An asset, it can be currency, it can be a painting, it can be a music, it can be an image, artwork, whatever it is. Everything is an asset, and you can represent assets on the blockchain. And once you define those assets, basically you can transfer them, you can trade them, buy, sell, do whatever you want with it. So there are standards that allow you to define, what are these assets. So there are two types of assets. One are these fungible assets. One are the non-fungible assets. A fungible asset is like your $100 bill in your wallet. If you have $200 bills, you can use any one of them. Both are the same. They perform the same function. It doesn't matter which one you use. Even though each one has a different serial number, for your practical purpose, both are the same. They're not unique. So that's why they're called fungible assets. A non-fungible asset is like a Mona Lisa painting. It's unique. There's only one in the world. You cannot paint two of them. Or a music from an artist. So the fungible tokens are represented by the ERC20 standard, and every blockchain has got their own versions of those ERC20 standard, similar. And then the non-fungible tokens use another standard, right? So I'm working in a startup that's actually focused on creating these non-fungible tokens. And of course, non-fungible tokens, there are many blockchains that help you do that. But what is unique here is that the way non-NFTs work is that, let's say you have a profile picture, that's very popular right now. If you're in the crypto world, your profile pictures, let's say you have a crypto punks and bored apes and stuff like that. So the way it works is that they're basically JPEGs or PNG files. That's it. But people pay hundreds of thousands of dollars for that. You'd be surprised. And the reason people pay for that is that because it represents a unit of ownership. It tells you that there's only one of this uniquely available, and you are the true owner of it. Okay. Now you can always do a right click and save that image. Anybody you can distribute it that way, but there's always a single owner, and that owner is you, because that is represented on the blockchain where your wallet is the owner for that. And a lot of people use that as a flex, in a social circle, social media and stuff like that. But the problem with all this is that the NFT is really a certificate of ownership of a digital asset. But the asset itself is publicly available. The image is available publicly, or the MP3 file is available publicly, right? Now, because blockchain by definition is open, so anybody can go to the NFT, inspect it, get the URL associated with the image, and the URL is typically stored on a place like IPFS, and you can take the image and view it. Everybody in the world can see it. That is great as a first generation of NFTs. But then, what if you want to store some information that is private? How do you achieve that kind of privacy on the blockchain? I think that's the problem that the startup I'm working with is trying to solve. So you can create what are known as secret NFTs. The secret NFT means that the ownership certificate is public. People will know Alan owns this NFT, but the content you put into it is not available to everyone. They will only the owner of the NFT, right? Authorized owner can actually view the content associated. You can think about a lot of scenarios you can do with it. For example, one of the common examples that people talk about is on death, a person wants to transmit the will. Right now, that is an example of a secret which you don't want shared before a person's death. Only on death you want to share it. And imagine, instead of going through a traditional way approach, you represent it as an NFT, and then you have information about death, assuming you have information about death being relayed on a public registry. You get that information through an oracle, and then automatically it triggers the transfer of the NFT to your family member to whom you've written that will, and that person can then open it and say what are all the holdings that are getting transferred to that person. So that's a classic use case of a private NFT. But you can do a lot more. Even you can think about, let's say, corporate setup and a company setup. One example is they say that Coca-Cola, the formula for Coca-Cola is very highly protected. It's in some safe somewhere with security and stuff like that. I imagine that what if we can represent that as a secret NFT, right? You don't need physical security. As long as only the authorized owners who represent them can actually go and view that information. So like this company confidential information can also be stored, as NFTs. Another things could be music. Let's say an artist, today artists, what they do, of course they have with record labels, they sign some agreements and stuff like that. But also, they stuff is available on YouTube and stuff like that, and maybe they get paid on the number of views and stuff. But really it's the record labels that hold the power in terms of what revenue flows, right? The artists, at least especially the smaller artists, really don't see much money in that. But imagine, artists can actually issue their new music songs as NFTs. Let's say I'm going to, it's like, in olden days, you have these limited edition LPs where you have 500 copies are, printed like Beatles songs like that. Let's say I meant 500 copies of my new song. And then people can actually buy that as a secret NFT because the music itself is there. And then you can actually listen to it, because once you own it on the blockchain will allow you to retrieve that and you can listen to it. Or an image, specific image, secret images, stuff like that. So these are all examples of what you can do with a secret NFT, and that is the technology that we're working on. We're using some off-chain computations, trusted execution environments, using chip-based securities to bring in this level of secrecy on the blockchain. Also, another aspect when you talk about these NFTs is some of this information has to last, especially family memories, bills, and all. Maybe they have to last for generations together. And if you store it in a traditional company, like whether it's I'm not taking a name, but example is a Dropbox or whatever. Maybe the company can go out of business, and what happens to all your data? Now, same way in the blockchain, also people use the open IPFS network for storing it. But again, if you don't pin the data, you lose the data. So again, we are making sure that we are able to store it in a more permanent storage mechanism, so that there's no point buying an NFT and seeing that after a few years, that the data service provider is not available. So making sure that we are creating secret NFTs that can last generations. Hopefully that will become the standard, going forward. So that's the idea.
And I'm guessing using Rust for the core of this technology, right?
Yeah, it uses Rust to build the core layer one blockchain and also the business logic associated with it. Yeah.
Actually, I have a question to ask that's, I guess, is when somebody owns an NFT or a Nifty, is it always going to be on Ethereum or could it be on any blockchain? Because there's multiple blockchains out there, of course.
Multiple blockchains. Every blockchain, as I told you, have got their own equivalent of Ethereum standards. So you can issue it on Solana, on Phantom, on Avalanche, near any blockchain you can issue it on. Technology is available where you can even bridge those NFTs across blockchains. I can mint an NFT on Ethereum. I can use a bridge. Bridge is a term that we use to connect different blockchains. So you can create a wrapped version of that NFT on another blockchain and view it and hold it and stuff like that.
If I have this digital image and I know that somebody else owns it, how can I find out which blockchain this thing is actually on?
Because every asset is uniquely identified by a token, basically address. You can go and look at the smart contract, and that will tell you that this is basically a wrapped version of Ethereum on Solana, for instance. So the base asset is issued on Ethereum, but you just have a wrapped version on things. So you can find out. There are all the the beauty of blockchain is that all the data is publicly available all the time using block explorers. At any point of time, you can go and inspect any block, any transaction, and you can verify for yourself without relying on anyone. So you can check that this NFT indeed was issued to your wallet address and on this particular block, and it was transferred to this blockchain on this day, and it's right now being held in this wallet address. You can see all those details.
Okay, it's pretty interesting. Yeah, as I said before the show with you when we were talking, is I've been reading a lot about blockchain recently, and I'm glad to hear that most of my understanding is there. But yeah, you also corrected me on a couple of things before the show, so I'm not going to talk about those because I don't want to look like a fool. But in any case, yeah, I appreciate your time on here and talking about all this stuff. I think, we already spent quite a bit of time together and we talked about some pretty interesting topics. I think I want to start to kind of wrap up on our stuff. Is there anything special that you wanted to mention before I ask you a couple of closing questions?
I mean, it's more about, I think one of the things that your listeners would be interested in is really Rust the right language to do web development. Maybe that's something that on people's minds. I think I'd say that Rust brings a lot of guarantees within a lot of the modern programming concepts. It kind of brings the best of many programming languages together in one place. And especially if you look at leaving aside things like performance and the memory management and stuff like that, what is also important is when you put something into production, right? You look for certain attributes. You want to make sure the software is stable, right? It doesn't leak memory, it doesn't go down. But also that if there is a problem, you have to debug, right? The most common problem people have is if something goes wrong, some wrong data is getting shown to a user. How are you going to track it down through your entire system? I think this is one of the places where Rust shines because of its unique memory model. The way it works is that normally when some piece of data is incorrect, right, compared to what you expect it to be, then clearly there is some code somewhere, some function, some module where this piece of data is getting mutated, getting modified. Now, typically in a traditional programming language, mainstream language, you have to run through the entire code base and look at every variable assignment and see whether this is being read or being modified or whatever it is. In Rust, there is one thing that enables you to do it much quicker, which is it elevates the knowledge of mutability of a variable to the function signature. Let's say I make a function call. In the function signature, and when I'm passing a value or a reference, I'm telling in the function signature whether there is a mutable reference or an immutable reference. So straight away, without even going through the entire code base, you know that this piece of software is only taking an immutable reference to a piece of data. So there is no way on earth this data is getting modified in this function. So you can go and focus your efforts elsewhere. So I think that is a very important aspect that I personally found when I look at debugging systems, that apart from the strong typing system, The memory model itself, helps you debug applications, structure applications well. So essentially, for production deployments, this is clearly one of the. It will help. I'm sure many people who've done production support will appreciate this particular aspect of doing any, not just web development, any production software with Rust.
Yeah, that's very true. I definitely agree with that. Now, I wanted to ask kind of some questions. What I like to usually ask at the end of the show is any kinds of tips and tricks you'd give or warnings you'd give to people who are beginning out in Rust, because I think we probably have a pretty good community of people who listen to the podcast who are interested in Rust, maybe are starting to learn it, could be struggling. Well, we've all struggled, right? It's not simple to learn Rust. There's a very steep learning curve. We all know that. So is there any kind of advice, tips, tricks, warnings, anything like that you'd want to let people know about?
Yeah. Let me tell you, my own experience was that I actually started learning Rust and I gave up. I gave up because beyond a point it became very complex. But I knew it was the right thing, but I still, couldn't do it. Then I came back after a few months, and again I tried. And based on my experience learning Rust, what I think it's important to acknowledge is that Rust is hard. There's a book that I read from one of those motivational speakers, I think Wayne Dyer or someone who started the whole book by saying life is full of problems. So once you start with that sentence and acknowledge it, then everything else becomes easier. So like that, you start with the sentence that Rust is hard to learn. Then based on that, you actually set the right expectations in terms of learning. There are lots and lots of features in Rust that have been built over time, and that's clearly addressed for different use cases, but you do not need to learn everything from day one. If you get intimidated by looking at certain syntax, a turbofish, or looking at a box of a dyn of a vec and all that stuff, don't or a mutex or an ARC, you may not even use many of those in day-to-day work. So I think you start with simple imperative statements, your standard if loops, for loops, all that stuff. Once you're comfortable, understand the memory model, the ownership, get your programs to compile, write the same thing in simple traditional style. And then you start to move on to more advanced concepts. For example, you can look at algebraic data types using enums and pattern matching that can come next. And then you can then start to look into more functional style of writing, which is more expressive for the person writing the code. But if you don't understand the syntax, it can be very intimidating to read. So try to solve the same problem first in a simple way, learn it, and then try to go on to more advanced concepts. There are things like generics, procedural macros, and all that stuff you may not even use. Most people won't even use, especially unless you're writing your own library or crate or a framework like that. So it's not necessary for you to look at all that and say, Rust is difficult to read. But I think you start small, but also be very consistent. When you start writing Rust, it's not the syntax. You have to understand the concepts behind it. And so what I found is once you start and stop and again come back, sometimes it's like you have to start all over again because you forget what you've learned. So make sure you every day spend some time, write small programs, be consistent, start small and then gradually expand it. I think that is, at least for me, I found that to be a valuable way to learn Rust. Ironically, the most loved programming language for 5-6 years in a row is also consistently being cited as the most difficult programming language to learn. So I find that the dichotomy very interesting.
It's kind of a love-hate relationship, right?
Yeah, I think it's more a love relationship because they want to learn it, and people they're struggling, but still they don't want to give up. That's the way I see it.
Yeah, and I also find it quite interesting because you're a very optimistic and pretty happy kind of guy. It sounds like, but I can't imagine you basically rage quitting because you're so frustrated with Rust. So it's interesting, but I'm happy you came back, right? And I'm sure you're happy you came back. And once you start to follow the master, aka the borrow checker and other kinds of things, then it's just life is just much easier.
Yeah, and a couple of more things I would suggest once you go beyond the basic proficiency of Rust. Two things which I found interesting are one is listening to talks by some of the people who build the core software or libraries and stuff. That gives you a lot of perspective about how they think about writing the software. And of course, reading a lot of other code, read open source code, look at how people have designed their data structures, look at how they're designing their traits, the mutability, how they are doing error handling. I think once you read other people's code, their functional style, you also start to pick up some of those pieces. So I think there's no substitute for writing code, but also reading code helps a lot when you look at other people's styles and you start to imbibe some of that into your own style of programming.
Yeah, the only thing that you have to be careful about is if you read somebody's code, but you don't understand it. Like that one, I think, is the tricky part.
Right. That's why I said once you go beyond a level of proficiency is when otherwise you will get intimidated and give up. Yeah.
Yeah, I'm already pretty intimidated, but I'm getting through it. I do it baby steps, so I'm still like, making my way through it. Otherwise, I'm enjoying my journey so far. Yeah, otherwise, yeah, I don't think I have anything else. I think we talked quite a lot, and I don't want to take up too much of your time. Is there, just going to give you one last chance? Is there anything else you wanted to mention before we sign off? Maybe you want to rep something that you're working on right now, aka the book, Cough Cough?
Oh yeah, so it's been a long journey for me writing the book. It's always a challenge, having a day job and writing book and stuff. But I still persist because I enjoy sharing whatever I learn. Hopefully, people don't have to go through some of the pain I went through initially writing web development. That was the motivation for writing it. So, if you're already sold on Rust, if you want to use it for web development, I suggest you go and head over to Manning's site and do some free chapter previews. If you like what you see, you can pick it up. And because there are always forums where you can ask questions and stuff. But yeah, so that's what I wanted to leave your readers with, our listeners with.
Oh, I just want to say one last thing too. I don't know if you know this, but I've heard this before and I've had it verified that if you guys like the book, even if it's a little bit more expensive, I recommend you guys buy the book from Manning directly, because if you buy it from Manning directly, more of a cut will go to the author. So if you buy from Amazon, the money that goes to Manning is less. Therefore, the amount that would go to the author would be less. So if you want to support the author, buy from Manning directly. That's just the only thing I have to say. And it's probably just going to be a few dollars more or something like that. And they always have a sale. So yeah, definitely go to Manning and check it out and buy from Manning to support him, because it's a big effort to write this book, right? A lot of sacrifices going on. So just wanted to make that very clear to people. So that's my last kind of plug.
Thanks for mentioning.
All right. Since, we've been on for a while, right? I really appreciate your time. I know you're a busy guy. I appreciate also your knowledge sharing, and I'm happy to hear that I'm not the only oddball out there who's doing Elixir, Rust, and Flutter. Those are my 3 check choices that I've been happy with nowadays. And I'm happy that somebody as a veteran as you in the industry also kind of agrees with at least most of my thoughts. So I have a happy day today. And again, yeah, thank you for your time. And maybe we'll have you back on when you finish the book, because I think you're still making changes as things go on, right?
Yeah, some small changes are there. And I really enjoyed talking to you. It was a pleasure. Thank you very much for having me on the show. And good luck with your Rust learning.
Yeah, maybe I'll ask you to review my code because my code needs some polishing.
Pleasure.
All right, thank you.